Have you ever wondered, just how fast does light travel? In 1 second, it can circle the Earth's equator 7.5 times. It takes only 1.3 seconds for light to travel from the Earth to the Moon. And this astonishing number took humanity a full 300 years to gradually measure out. Today, let's explore the epic journey of humanity's pursuit of light and understand the genius experiments that changed the history of science. Before the 17th century, everyone firmly believed that light arrived instantaneously with infinite speed. Even great thinkers like Descartes were no exception. Then, in 1607, Galileo stepped forward. He said, "No matter how fast light is, it is finite, and I can measure it." His experiment was very simple. He placed two people on two mountaintops, 1.5 kilometers apart, each holding an oil lamp. The moment one person uncovered his lamp, the other, upon seeing the light, would immediately uncover his own. Galileo wanted to calculate the speed of light using the time difference between their actions. But unfortunately, light was too fast, over a distance of 1.5 kilometers. Light takes only 5/10,000ths of a second. The human reaction time simply could not keep up. The experiment ultimately failed. Yet Galileo's hypothesis, like a seed, planted the groundwork for humanity's future exploration of the speed of light. The wait would last 69 years. In 1676, Danish astronomer Ole Rachmer, while observing the moons of Jupiter, discovered a puzzling phenomenon. Each time this moon orbited Jupiter, it would enter Jupiter's shadow, producing an eclipse of the moon, much like a lunar eclipse. However, he found that when the Earth moved farther from Jupiter, the observed time of the eclipse always came more than 10 minutes later than predicted. Rachmer suddenly realized it wasn't that the moon's orbit had changed, but rather that light needed more time to travel from Jupiter to the Earth. He boldly predicted that the eclipse originally expected on November 9, 1676, would be delayed by 10 minutes. The observation perfectly confirmed his prediction. Later, the scientist Christian Huygens, using Rivmer's data, calculated the first numerical value for the speed of light in history, 214,000 kilometers per second, although it deviated from the true value. It was the first time humanity had assigned a concrete number to infinite light speed, a milestone of immense significance. Another 173 years passed. Humanity finally moved beyond astronomical observations and measured the speed of light on the ground. In 1849, French physicist Hippolyte Fizeau designed a truly ingenious device, a rotating gear wheel. His thinking was clever. Designed a truly ingenious device, a rotating gear wheel. Light from a source passed through a gap in the gear wheel, traveled to a mirror 8 kilometers away, and the mirror reflected it back. When the gear rotated quickly, the returning light was blocked by a tooth. But when the gear reached a certain critical speed, the reflected light would exactly pass through the next gap and become visible to the observer. By knowing the gear's rotation speed, the number of teeth, and the distance light traveled, one could calculate the speed of light. Fizeau's final measured value was 315,000 kilometers per second. The error was only 5%. This was the first successful measurement of the speed of light on the ground. A perfect dance of science and mechanical ingenuity was the American physicist Albert Michelson. From 1879 to 1926, he spent 50 full years dedicated to a single pursuit, measuring the speed of light. He improved upon previous experiments, using a rotating octagonal steel prism instead of a rotating mirror, thereby extending the path of light. He also used precisely measured rotational speeds of the prism to reduce timing errors. He built a 1.6-kilometer-long vacuum tube, evacuated to nearly perfect vacuum, allowing light to reflect back and forth inside, minimizing interference from air. In the end, Michelson measured the speed of light to be 299,796 kilometers per second. He also used precisely measured rotational speeds of the prism. The error was only 4 kilometers per second. This was the most accurate record at the time. After Michelson, the techniques for measuring the speed of light became increasingly advanced. In 1949, scientists used radar to measure the speed of electromagnetic waves, obtaining 299,792 kilometers per second. In 1952, the microwave interferometer pushed measurement precision even higher. In 1972, the advent of the laser brought the measurement of light speed to an unprecedented level of accuracy. Finally, In 1975, the International General Conference on Weights and Measures fixed the speed of light at 299,792.458 kilometers per second. Even more remarkably, in 1983, the scientific community made a momentous decision to define the speed of light as an exact constant, no longer something to be measured. From then on, the definition of the meter was also rewritten. The distance light travels in 1/299th, 792,458 of a second in a vacuum. Once upon a time, measuring the speed of light required entire mountains, planetary orbits, and vast open fields. But today, on an ordinary laboratory table, with a track just 600 millimeters long, light speed can be measured precisely. The Brolight BEX8208 light speed apparatus measures light speed in air at approximately 3.010 meters per second, remarkably consistent with Michelson's lifelong achievement. It uses the core technology behind today's LiDAR and depth cameras, iTOF, indirect time-of-flight. By measuring the phase difference between emitted and returned light, the device calculates light speed with picosecond precision. What's even more remarkable, it also measures the speed of light in solids and liquids, calculating the refractive index of the medium. Humanity's 300-year pursuit of light has never been just about a number. Behind the figure 299,792.458 kilometers per second lies the dedication and perseverance of generations of scientists. The speed of light is the cosmic speed limit and a beacon for the progress of human civilization. As long as we stay curious, even running after light itself, we can reach a farther future. BEX8208 iTOF Lightspeed Apparatus, honoring 300 years of lightspeed pursuit with modern technology. Thank you for watching this episode. See you next time.